Howdy, howdy, howdy. Hello, hello. Just trying to get things ready here. How many people are here? How many people are here? Let's see. There's, wow, 13 of you. I'm sorry. I was been late. Well, I'm not late. I've just upgraded my machine. And I had that much time left. Okay. I'm really, really glad. I hope everybody had a Merry Christmas. I did. As a matter of fact, I've been working so hard, I haven't even had time to have my pumpkin pie with whipped cream. So I'm going to have that later. Wow. Let me tell you, I've been busy. Busy. And what we are going to do tonight is I'm going to cover the 3018, and I'm going to cover it from A to Z. Okay? So, let me just get rid of some stuff here. And let me, I'm just trying to think of the best way I can mount you. Just a second. Just 1 second. Okay. What I gotta do is I just gotta clean my mouse pad, or I mean my PC off just a little bit so I can attach my camera. Like I said, I've been really busy today with this upgrade, and I wanted to get it finished for you guys. Okay, let me see here. I'm trying, just a second. Okay, now, let me see here. Let me turn you guys around. Whoa, there we go. There we go. There we go. Let me see. I'm trying to get you guys in a good place where you can see what I am talking about. And okay, that should help. Alright, this is a upgraded 3018, and I have just got it plugged in and working, except for my Z-axis quit working. But I'm going to show you how to do some troubleshooting. Okay? First of all, the 3018. One thing people have to understand with the 3018. The 3018 is not, and I repeat, is not a industrial machine. In other words, this is a toy, hobby, home CNC machine. Okay? With that being said, you cannot, on the 3018, it is not recommended to run any tools larger than 1/8 inch. Now, why do they say that? Well, I'm going to tell you why. As you figured I would. You see that spindle motor there, right? Well, this here is your standard spindle motor. Okay? This little piece of crap costs $4 retail. There are no bearings in here. There are only bushings. Okay? So, if you run a tool bigger than 1/8 inch, you are putting a heck of a lot of pressure on this stupid little motor. Okay? You will burn it out. You will burn the brass bushings right out of it. These motors, if you do not run them carefully, they will last you a month, basically. Okay? So, enough said about this little motor here. What I highly suggest everybody does is take this motor and throw it in the garbage and get yourself that Gemitsu 775. It is a direct drop-in replacement. And the only thing you get, what I highly recommend then, is to get Mark's RPM control. Okay? Now, I haven't had a chance to see who everybody here who's on here. So I'm just going to go through real quick. Hi, Colin. Thanks for coming, man. Yes, had a good Christmas. Thank you very much. Hope you did too. Bill McDonald. Nice to see you here, man. Cindy. How you doing, Cindy? How's things up in your end of the woods? Morianne. Hi. Thank you for doing this. My name is Viking. Hey, Viking. 16 years old. And I got a 3018 Pro for Christmas. Whoa, you are one lucky kid. And you have come to the right place, because I am going to teach you how to use it and not abuse it. Okay? And if you listen to what I'm saying, and I highly recommend that you get a piece of paper and a pencil and write down notes. Okay? And I'll tell you one little thing. If you have that 3018 and you just got it and you just put it together, well, you're going to find out now that we're going to go through things that you're going to say, oh, I wish I knew before I put it together. But anyways, Viking, got you covered, buddy. I'll get you going on this machine in a safe way without tearing your machine up, okay? Robert Lozano, how you doing, buddy? And Jessica Pippin, Steve Morigi. No sound. Okay, you got it now. Okay. Brian Skinner, nice to see you here, man. Glad you could make it. Okay. Okay, let me see. Somebody just sent me a messenger message, which I cannot reply to. Now I'm going to show off. Remember I told you about this little motor here, okay? You know when you wind these up, when you turn them on and they're doing 9,000 RPMs and you can't even hear yourself think? Well, guess what? Watch this. That's full RPM on my machine. And the only thing, that's all it is actually this here part, it's that fan, which is the most out of balance thing there is. I'll bet if I took that fan off right here, it would be completely silent. Now this is full RPM, 12,000 RPMs right there. Okay? Alright, now let's get started on the 3018. And what I'm going to do is I'm going to pull you out of here. And I'm going to do it the old manual way. Okay? Come on, there we go. Now I'll tell you, this I started on that at 2 o'clock today. Or about 1-ish. But anyways, I have been working my butt off to get that installed and everything. And guess what? I have a problem with my stepper motor. But that's okay. I can fix that. Okay, let's get down to some terminology. And first of all, because there's a lot of new people on here, very, very, very new people that have just put their machines together last night. So, we are going to do this for them. First of all, you got to know the name of the things on your machine. This is not called a thingamajig. This is not called a doohickey. This is not called a whatchamacallit. Okay? Everything on your machine has a specific name. And in my group, I require that people use the correct names of things. Okay? First of all, the things, these rods, these polished rods, they're 10 millimeter rods, and they are what your table slides on and what your X-axis slides on. Remember always, this is your Y-axis. This is your X-axis. They are always in that order. X, Y, and Z. Okay? X, Y, and Z. Okay? Now these are called ways. This is what the table rides on, slides on, and your X-axis slides on. They are called ways. W-A-Y-S. Then you have your lead screw. Okay? Now your lead screw, obviously, is what moves your axis, your axis back and forth, okay? Now, the lead screw On the back here, you have a lead screw follower nut. Okay? It's spring loaded. When people ask me, what is that? Why is it spring loaded with that second nut on there? Okay. That is what they call a anti-backlash nut. Okay? Now if you take a screw and you hold a big nut and you have a big screw, okay? And you hold that nut steady and you screw that screw, you're going to feel it going in. And then you stop and then you turn it backwards. You're going to notice that you'll be able to turn it backwards a little bit before it even catches. Okay? That is backlash. So, we don't want that slop in this lead screw. So that's why we use anti-backlash nut back in here and underneath your table. In conjunction with your follower nut, you have a anti-backlash nut. These here, these are called collars. This is your collar between your lead screw and your stepper motor. And you have 3 of them. You'll have one on the back of your table back here. And you have one right up in here. And one right there. Okay? One for each axis. Now, one thing a lot of people don't realize. Just the name of the machine itself. 3018. Okay, where did they drop that thing out from outer space? 3018. Very simple. Guess what? Because the capabilities of this machine, it can carve a 30 centimeters by 18 centimeters. That's right. 30 centimeters here and 18 centimeters that way. So that's why it's called a 3018. People that have a 6550 laser machine, guess what? That machine there can laser engrave 65 centimeters by 50 centimeters. Okay, so the name of the machine is the actual size of your carving area. All right. Okay, so I think we're done for tonight. Not really, not really. We haven't even started. I'm going to tell you a couple things that you have to beware of. And this is no joke at all. People that are watching here can verify this, and they will tell you in a heartbeat. I'm going to do a little explaining about CNC and the stepper motors and such. Okay? First of all, what does CNC mean? CNC stands for Computer Numeric Control. In other words, that's all you're sending from your laptop. You're going to be sending G-code, which are just numbers, and it controls how everything moves. Okay? Stepper motors. Stepper motors. Stepper motors use a lot of power. Okay? A lot of amperage there. Now, these stepper motors move by just on-off pulses. The pulse, if you look at it on a screen, it'll look like this. Up, up, down, like that. Pulses. On-off pulses. With that being said, in electronics and the electronical world, you have something called induction. In other words, very simply put, these wires that go to this stepper motor, you have really high amperage signals going through these wires, and they are going on and off, on and off, on and off. So, guess what? Those wires there are exactly like an antenna. They are just like an antenna. And guess what? If your signal cable the cable that goes from your computer, that goes over to your machine, if your signal cable is laying very close to stepper motor wires that are back there, and if you don't have your wires put up on a wire harness, they will get caught and you will tear them out and you will be in trouble. Be careful with your wires. I will show you how to make that. It's really, really simple. I'm not even finished with mine because I have to reattach it here because I haven't gotten that far yet. But that's how it is when it's attached. Okay? Now, that keeps my wires away from everything else. They can't get hung up on anything. And the wires are away from my signal cable that is plugged in the board. Back here, the signal cable that goes, and this goes over to my computer, okay? It is totally away from those stepper motor wires. Because what happens, if you don't do that, you'll be in the middle of a project, and I can guarantee you it will happen in the middle of a project. Not in the beginning. It'll either happen right towards the end or right in the middle. But what happens is, as you're sending your G-code from your computer to your machine, okay? And that cable is laying next to stepper motor cables. And those stepper motor cables, they are just pushing out bad noise. It's called electrical noise is what it's called. And it's pushing it right into the cable, your signal cable, and that G-code that's going from your computer into your machine, guess what? It gets garbled, and all of a sudden your machine does not recognize it. It might move. It might jump from one letter and keep printing the letter a half an inch further away. You can get all kinds of weird problems. Or it just might lock up and say, sorry, we had a problem. Okay? That is a very well-known problem in this world. Now, for you people that have put your 3018 together and you have not met me or seen my videos or anything, well, what I highly suggest you do, and this is actually true in the whole CNC world. I'm talking machines that are 20 foot high. The biggest problem we have with CNC machines is high frequency vibration. High frequency vibration due to the spindle motor and your carving tool. Those high frequency vibrations go throughout your whole machine. And guess what? Those high frequency vibrations are exactly like an Allen wrench. They'll loosen up every screw you have in your machine. And if you think I'm joking, then don't do just forget what I'm telling you. I have literally seen these machines literally fall apart. I mean, hanging. The whole thing had fallen apart. Because the person that put the machine together did not use, let me go get it here. This is where I just put all my stuff together here. And what I recommend people use when they are building their machines is, just a second, I'm trying to find, here we go. There we go. Sorry. This right here, Loctite. It is called blue. This is blue, not red. Blue Loctite. And this number right here, 243. If you use red Loctite on your screws, you will never get them out again. Okay, I'll repeat. If you use red Loctite on your screws, you will never get them out again. And if you have a problem with your machine and you need to take it apart, you are screwed. Okay? Blue 243 Loctite. And what you do is very simple. You start right here and you take this screw out. You put one drop of that blue Loctite on it. You put it in and snug it up. Tighten it up. Don't over tighten it. You don't want to strip the threads. Just when you snug it up, just a little bit, just tight. When you're done with that one, you go to that one. When you're done with that one, you go to that one and that one and that one. Every single screw. I'm talking every screw. Every screw that you can find on your machine, you need to put Loctite on. Okay? So that will keep your machine from falling apart. Okay. Now, how, these machines are very, very simple. Okay? Okay. They're very, very simple. You have a controller board. And that's all that controller board does is controls the hardware on this machine. And it's really simple hardware. Basically, we have 3 motors, 3 stepper motors. One here, the X, and you have Y in the back, and you have Z up here. Okay? That's all we have. 3 stepper motors. Okay. With that being said, then there is no more movement. You have your table moves forward and backwards. Your X-axis moves left and right, and your Z-axis moves up and down. Okay? So, there is not much that you have to worry about with a machine. And troubleshooting is a breeze. The only thing you have to do, if you are going to troubleshoot something, you have to look at what the problem is, and you have to think logically. Now that's the whole trick right there. The whole trick is being able to think logically when you have a problem. So, for example, right now, I have found that this stepper motor that I put on here, for some reason, it does not want to move. When I use my Z up, nope, it doesn't. Yep, it doesn't want to move when I use the Z axis. Okay, so now, right now I said, okay, my Z axis does not go up or down. Well, how are we gonna troubleshoot that? The first thing, whenever you're gonna do anything on your machine, you just pull the power plug out. Okay, that's all the power plug. Now I'll tell you a little secret. When you have that power plug out, you're still gonna get red lights in the back. And let me see if I can even show you that. Yeah, there you can see. Those are the red lights. And they're actually blinking. The one blinks. That's your communications. And it's lighting up because it is getting 5 volts from the USB. So those 5 volts are that's what is lighting up the board right now. When I plug my power plug back in, then what I do is there's going to be another light that comes on back there. So just because you see red lights back there does not mean that it's unplugged. Now you don't have to unplug your signal cable if you're going to mess around with your machine electrically. No, so right now, what I'm going to do is I'm going to pull out this connector out of my X-axis. Okay? I just pulled the connector out. Now, I am going to pull out, this is what I just pulled out from the Z-axis. And what I do is I just go right here in here and I plug my Z-axis into my X. Now watch this. I'm going to go and I'm going to plug in my machine. Now, my Z-axis here, up and down, should be controlling this X motor. So now I'm going to try to find out, is there a problem with my wiring? Or is there a problem with my stepper motor? I have a feeling that it's a problem with the stepper motor, but I need to check my wiring. So I unplugged the X. Here's the plug over here for the X-axis. And I plugged my Z-axis into it. Now, let's see if it moves. Nope. So now right now, it is not moving. It's not moving my X-axis at all. I'm going to turn this plug around. Let's see. Then try it again. Oh, it tries to, but it's not working. Okay, so now I have found out that there is a problem. There's a problem coming from my wire, from my board. So now I'm going to plug my X-axis back in. Okay, I just plugged that in and push my power in. Okay, now let's try oh, it's moving. So there's nothing wrong with my X-axis. Now my X-axis is back to normal. I got that wire in there. So this is my problem, and it looks like I might have a problem on the board itself. Okay? So this is exactly how you do troubleshooting. Now I'm going to try one more. I'm going to try one more here, and what I'm going to do is I'm going to go back here and I'm going to pull this wire off of my, and it won't reach. I was going to try that. I was going to try my Y-axis on that stepper motor to see if it was working, but I can't. It's not long enough. So I'm going to plug this all back in now, and I can move everything except my Z-axis. So I'm just going to try moving my X-axis now, and I'm going to move my Y-axis. Okay? See, everything's working fine. One thing you have to realize, any of these buttons, you have to realize one thing here. These arrows mean move my spindle in this direction. Okay? If I click on this, it is going to move my spindle to the left. Okay? And that's what it's doing. Now, a lot of people think, oh, if I press this, the table is going to come forward. Wrong. You are not moving the table. You are moving your spindle. So you, on this one here, you are telling it, I want to move my spindle forward, which, guess what? Moves the table backwards, okay? But you're bringing your spindle forward. That's what we wanted, right there. If I want to move my spindle towards the back, then I move it and the table comes forward. Okay? All magic. Now, first of all, let me tell you a couple things here. Let me just move this back. Now, on your 3018, you see how clean this is? There's nothing on here, okay? That is because we do not put oil, or the only thing that is recommended to put on this lead screw here is graphite. 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 It's a dry lubricant that you can put on here. If you put oil on here, guess what happens when you're doing your carvings and all of that dust is falling right off onto here and it sticks to the oil, and as it's going back and forth and your lead screw follower nut back in here, it will get caked up with sawdust. And guess what? It will get caked up like cement. And it will stop up and your machine will not run. Okay? And you will risk burning out your stepper motor or your board. Do not put anything except graphite on this lead screw, or you are going to be asking for a lot of problems. Okay? And that's not cool at all. All right. The 3018. It is a very high precision machine. Okay? And when I say high precision, I mean it. Do you know that these machines are literally, the accuracy of these machines is 0.005 of a millimeter. 5 thousandths of a millimeter. Now, you're wondering how big that is? Well, guess what? I'm going to show you. That is right there. That is 1 millimeter. Right there. That is 1 millimeter opening, okay? And I'm talking about this, the little crack. That is 1 millimeter. Okay, now take 5, divide that up into 1,000. Okay, divide that little opening there into 1,000, and put 5 of those together. That's how accurate your machine is. These things are dead on. And I mean, the things that you can carve with them, I mean, just like this here. Well, let me see, let me get a good picture of that. It's kind of hard to see. There we go. Put a little bit of light on it. I mean, you can carve, this is done on plexiglass, which is, actually, I just found it back in the floor, so it's all scraped up and everything, but try to get it in focus. There we go. So you can do really cool carvings with the engraving tool. Okay? And I'm going to talk a little bit about collets. If you people have never been, if you've never used collets before, well, guess what? And you got to learn how those work too. It's not just. When you take your collet, your nut, out of that machine, okay? You see this is your collet here. And you only get one with your machine. Okay? You only get one. And it's an 1/8 inch. Or 3.175 millimeters, which is the same thing. Okay? Now these collets, if you take yours out and you tip it upside down like this, and if it falls out, you have been doing it wrong. Okay? These should not fall out. Now, I have to put you back up here. Just hold on for 1 second. Okay, now I'm gonna show you these collets. When you are gonna take it out, when you're gonna take the collet out of the collet holder, what you have to do is you have to cock it. So you have to keep turning it, and you'll feel there, right there. It just clicked, and it is completely cocked. Okay? Then, what I take, anything, a little piece of wood, but let me just give you some light on this. Okay, you see how it's cocked right there? And that's all I do is take a piece of wood or pencil or whatever, and I push. And there we go. It just came out. Now you see this ridge here, inside of here, there is a ridge in there. And that's why when you put a collet inside the holder, what you do is you press it, you just press it until it clicks. And then you hold it upside down and see if it doesn't fall out, it's correct. Now, I'm going to talk a little bit about collets. A collet, you see all these grooves? Well, guess what? You know what these grooves are for? Is because this here is tapered. This is tapered. And the inside of the shaft on the motor is also tapered. So as that nut pushes that collet up, okay, that nut will push that collet up, and what it does is it closes. It closes all of these veins. It tightens up around the tool. All right, supposedly, okay? Now, if you do a carving, and you're going to change tool, let's say you're going to use a 2-tool project with a roughing tool, and you're going to use a 1/8 inch tool, and you're going to hog out all that wood. Then you're going to put a detail tool in there. Whenever you change tools on your machine, take your collet out and clean it. Very good. Make sure, I'm just going to show you a little bit here, just a second. Like right here, these veins. Now, these veins, guess what? If you have sawdust in these veins, let's say you have sawdust packed up in one of them, guess what's going to happen? When this here gets crimped up in there, those veins are not all going to crimp evenly because you have garbage in one. So guess what? Then your tool is going to be doing this. Instead of running perfectly straight, it's going to be off center. A lot of people will think, my God, what is wrong with Paul? Going into such detail about such small things. I just told you before what the precision of these machines are. Okay, I told you what the precision is. These machines are just like a computer. And I'm sure you have heard the term on computers, crap in, crap out. Now, I tell everybody in my group, if you put every number that you put in easel, if it is 100% correct and dead on, I mean dead on, if it is 3.1 millimeters, then that's exactly what you should put in. And with that being said, you cannot own a CNC machine without owning a set of calipers. These calipers, every CNC operator, this is their best friend. Because everything you want to do, you want it to be 100% accurate. Okay? And by what I mean by that is I want you to measure exactly everything you do on your machine. Okay? And my batteries are getting low, I can see. So, use a set of calipers. Now I'm going to show you real quick. Calipers, this here is for outside measurements. Okay? I want to see the size of this lighter. I can measure it like this. Now, if somebody was to say to me, well, Paul, how big is that hole right there? Well, I can't measure like, you don't, in this game here, we do not eyeball nothing. You don't go like this and eyeball it. No. You use inside. You see that there? This is the inside measurements. So what I do there, watch this. I put my calipers in there and I pull them out and I can say right there, it is 19 millimeters. Exactly 19 millimeter hole right there. That is your outside. Then if somebody was to say, well, how deep is this? If I put this on the table, here, how high is it from here to the table? What's the height of this? Well, guess what? If I just do this, oh, let me just hold on to this for a second till I get it. There. That is your depth gauge. Your depth gauge. And that is 315 millimeters. So you just put the edge on here like this and you push down. There we go. Just like that. 315 millimeters. Okay? So now you know how to use calipers. If you are going to own a 3018 or a CNC machine, excuse me, you need a set of calipers because everything you're going to do needs to be 100% dead on. And I'm going to tell you a little secret. If you are 100% dead on with every measurement you do on your machine, guess what? You are going to eliminate 50% of the faults. Right there. Just boom. Just by doing that. Okay? The next thing is double check everything you do. And before you even run it, you triple check it. Okay? As far as maintenance, I tell people, keep your machine clean. If you have a filthy machine, it is not, I'll guarantee you it will not last long. Keep your machine clean, and while you are carving, use something like this, just a small hand vacuum cleaner, and vacuum around as you are carving, because your machine does not like to recut wood that's already been cut. In other words, it doesn't like cutting sawdust. Okay? So, as you're carving and stuff, Keep your machine clean. Alright, now let's see, what else do we have here? I'm just trying to think of anything else I can think of. Oh yeah, yep. Whenever you are going to put a tool in a collet, okay? Whenever you're going to put a tool in a collet, let me find a right size tool here, and I'm just going to use an example of an old wore out. I have a wore out engraving tool here, and boy, now when I get onto tools, now I got a lot to talk about. Okay, this is an engraving tool. I'm sure you recognize this one here with the little blue hat, the rubber cap on it. From here to here is your cutting tool. From here back, this is the shank. Okay? This is the shank. Now, whenever they ask for a tool size, the machine could care less about the shank. They are not asking you the shank size. In easel, where it's in bit, when you're going to put the tool size in, it is not the shank. It is the actual cutting tool size. So, for example, here, the smallest I have here is 0.8 millimeters, 1 millimeter, 1.5, and it goes up, and I got up to 1/8 of an inch, 3.175. Guess what? All the shanks are 1/8 inch. All the shanks are 1/8 inch. But when you are going to put a number in your machine, it wants to know the exact diameter of your cutting tool. And when you are going to measure a cutting tool, just to verify, and I highly suggest that you do that too, that you double check everything. Do not eyeball and say, oh, well, I think that's a 1/8 inch, because your machine is going to think that you put the right number in there, and your machine is going to do the correct thing in accordance with that tool. And if your tool is the wrong size, then guess what? You done screwed up. Okay? So right there. Okay, now I'm just going to measure it, and I just slide the cutting part of the tool. You see, I'm not getting any of the shank, nothing else except that tool, and this is 0.182. Okay? But this is actually, I mean, you can measure it several times, and depending on how you turn it, if you turn it a little by little, there's some edges that are higher than others. Okay, so you see how my numbers are changing, but it's roughly 0.84, but we call this a 0.8. And if you feel it, it has kind of like rough edges, not just the flutes. Now, what's a flute? Since we're talking about tools. Since we are talking about tools. There we go. Just one second. Let me get my tools out of here so I can show you. Okay, I have an up cut here, and I have a down cut, and I have a I have a ball nose here. I'm going to pull out to show you so that you will understand what the different tools do. Okay, let's see here. I gotta, just 1 second. Just bear with me. Okay, there we go. Well, I caught you. I caught you, so you didn't go on the floor. Just a second. Okay. I almost lost you guys. I almost lost you. Now there's people that have asked, what is a fishtail? Okay, if I get it just, wait a minute. Let's see if I can turn you around here. Okay, this is easier to show you here. Okay, now, what does that look right there? What does that look like? Does that look like a fish? If I turn it a little bit more, it kind of disappears. But there's your fishtail. Right there. There's your fishtail. Okay, that's why they call it a fishtail. It's actually basically flat across the edge here. Then you have a ball nose. Here's a ball nose. There you go. You can see it there. It's rounded at the end. This gives nice smooth edges. If you're doing any kind of contouring, these are very cool for that. Okay? And as I mentioned, this engraving tool. Now, if you have a piece of paper and a pencil and you're writing things up, this engraving tool, the size that you are going to put in easel, as far as this tool is concerned, the tool size of this engraving tool is 0.1 millimeter. I will repeat that. 0.1 millimeter. That is the size of the tool right here. Right at the top. That's what we're measuring. So, but that is the number you are going to put in easel for this tool. Now, this tool should never, never, never be used over 2 millimeters deep. It should, I mean, this is not a carving tool. This is a engraving tool. This tool is for doing cool stuff like this right here. For very, now this here, this was cut with a engraving tool. And guess the depth here, I'll bet the depth here is a half a millimeter, 0.5 millimeters. And this is what you get, just like that. If you go deeper with that tool, you will ruin your tool, you will ruin your project, you will lose detail, a lot of detail, and you will add on tons of time on your project. This engraving tool is only for very, very fine engraving on plexiglass or wood. Even on wood, you never, never go deeper than 2 millimeters. Now, since I'm on that, talking about that right now, the depth. And this is something that I have experienced teaching about 300 people. It's a common problem, well, it's a downfall that every beginner has. When new people post projects in my group and they say, look at this. This is my first project. And I'll tell you what, they impress me. I mean, a lot of cases, I am very, very impressed at what the group does. But I am a person that if you post a picture in my group and I see that there is something wrong with it, I am going to tell you in a nice way. Okay? I'll tell you, my God, that project you just did is gorgeous. But, guess what you did? You fell into the beginner's logbook. You have signed yourself in. And you have gone way too deep. Yep, that's exactly what I mean. I mean, beginners think they have this thing in their head that if I carve something deep, it's going to look cool. Well, guess what? And this you better write down on your piece of paper. You are going to find that the prettiest carvings that you do with your machine are going to be between 0.5 millimeters deep and 2 millimeters deep. Between 0.5 millimeter and 2 millimeters deep. That is where you are going to have your most beautiful carvings. Okay? When you start going deeper, you're going to start losing detail. When you go real deep, for example, just an example here. I'm going to use these letters as an example. If you go real deep on a carve, that little part of the A might break out on you. Or that in the middle of the B might break. Or up in here, the S, right in here, that part there will break off on you. And it looks like garbage. And that's because you went too deep and you went too much and there's nothing there to, like for example, that E that would crack right off and be gone. Do not carve deeper than 2 millimeters unless there is a specific purpose for it. Okay? I'm going to show for you people that, I mean, my members have seen all this before, but this is just a show. Guess what? Those there are inlays. These are inlays. This is pine, and this here's cedar wood. These, what I did was I cut out pockets, cut out these pockets, and then I went right back and I took this off of here, off my machine. I put the cedar wood on. It was 2.5 millimeters thick cedar. And I cut my letters out. And guess what? They popped right into the hole, into the pocket. And I mean, and this, like I told you, how accurate this machine is. Look at these inlays. There is absolutely no air between the cedar wood and the pine. There's absolutely no air. Okay? Ben's, I mean, I'll tell you, you're asking about a laptop. Really, the easel does not require a lot of resources. You can get yourself, like a $300 laptop and you'll be good to go. I just got me a brand new one. I paid $300 for it, and it is a Hewlett Packard. Okay? Now you see here. This here was just carved out, just for the heck of it, on a coaster. And this is 2 millimeters deep. And you see, it's actually too deep. It is too deep. So, keep it shallow. And the cool thing, get this. If you go too deep to begin with, you're screwed because you can't put wood back again. If you go too shallow, guess what? You can just run it over again. run it, put it deeper, put a deeper depth on it, and you can run it again. You still have material there. Okay? But if you go too deep to begin with, then you're screwed. I'm going to turn you back over here just a little bit because I want to show you some tools. Now, you hear the term upcut, downcut. Well, this tool, I'm going to be turning it clockwise, the way it's supposed to. Whenever when you're looking down on top of your spindle should be turning clockwise. Now watch this tool as I turn it clockwise. Look what the flutes do. You see how they're going upwards? Okay, and they're lifting the dust and they're lifting what that's been cut out of the hole. But guess what? At the same time, it also lifts up the edges of the wood. Okay? Just keep that in your mind. Just keep that in mind because I'm going to, during this marathon, I'll be talking about all of this. Okay, now this is a down cut. Now I'm going to turn this clockwise also, and look what happens. Those flutes go downwards. They are pushing everything down, even the edge of your wood. So I'm going to show you later on. It won't be. I don't think it'll be tonight, but tomorrow night. What my whole game right now is, I want to teach you right now everything there is about the 3018. Okay? I want to teach you the machine itself, what everything is called on the machine, which we have gone through. The motherboard, or the main board, and this is your Z-axis, this here is your X-axis, and this is your Y-axis. I want you to understand all the parts of your machine. I want you to understand how things work on your spindle when you're using your spindle. Okay? That's why I want you to understand collets, tools. Whenever you are going to put a tool into a collet, remember I told you, you see here, this is a good explanation because the gold here is where the flutes end, where the cutting edge ends. You see here? Actually, when I show you this, right up here, this part here is the only part you can cut on. Then it tapers up, and then you have your shank. Now, whenever you put a tool in a collet, okay, the entire shank the bottom of the shank, right there, should be at the bottom of your collet. You want to keep your tool as short as possible. Keep it as short as humanly possible. Because, believe it or not, these tools, the longer you make it, they wander. They actually wander in the wood. They bend. So you want to keep them short, short, short to keep them rigid. Okay? So, these are flutes. These here sharp edges are flutes. Okay? These will cut you. If you have a very good carbide tool, these will be sharp like razor blades, and they will cut you. So don't try to grab a tool and pull it out, because if your fingers slip, guess what? You just got yourself a couple cuts in your finger, okay? Don't do that. Don't grab a tool and try to just pull it out, okay? So, like I said, I'm going to be talking mostly tonight just about the 3018. And then what I'm going to do tomorrow night is we're going to hit up on easel over here. And I'm going to go through easel with you, and I am going to teach you the ins and outs of easel, what to do, what absolutely not to do. Okay? Now, everybody in my group, they know I have two pet peeves. And the one is inches and CNC do not play well together. In other words, I teach everything in millimeters. If somebody comes to me and says to me, Paul, I have a problem with my machine and I'm trying to run it so many inches per minute, guess what? I'll hang up on him. I won't even talk to him. I will not talk to you about a problem if you come to me with inches. The only time in my group it's allowed to use inches is when you are talking about the size of a cutting tool. Now, we do say this cutting tool here, the actual cutting diameter is 1/8 of an inch. Okay? This one here is 0.8 millimeters. Okay? So, and we say a tool has an 1/8 inch shank. Or a tool like this has a 1/4 inch shank, which you should never run a tool any bigger than 1/8 inch on this machine. Now, remember I just showed you the up cut, down cut. Well, this is a straight cut. Look at that. Exactly straight cutting edge. Right there's one, and there is the next one. This is a 2 flute. These are flutes. These are called flutes. And this is a 2 flute. This one here is a, this is a 2 flute. And this one here is a 2 flute. Okay? And this one here, you can look at it and you can't even tell if it's 2 or 3. But the cutting edge are called flutes. F-L-U-T-E-S. Okay? Now we got all this hammered out and out of the way. So I'm not going to have to yell at people about using inches, right? Right? Because nobody in my group uses inches. Right? But I'm going to show you as I go along in this marathon, tomorrow night and the next night and the next night, I'm going to show you people why inches suck in the CNC world. Okay? Now, you're going to find that by using the metric system on your CNC machine, that it's a lot more accurate. Much more accurate and much easier to use. It is so easy. I mean, using millimeters, people say, oh, I don't understand millimeters. I just don't understand millimeters. Well, guess what? You know, they say, I just can't figure it out. I mean, there is no difference. For example, do you know how to read a thermometer? You know where you count from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Well, then guess what? That's all it is metric. You're only counting to 10. If you have 10 fingers, you don't even have to take your shoes off. So that way you have it covered, okay? So inches and CNC do not play well together. And the reason I say that is you look at inches, and inches are divided into these stupid fractions. They are the most idiotic things on the earth. Now, what would you rather add together? 13/16, 7/8 plus 3/4 plus 5/16 plus 31/32. Would you like to add them together, or would you like to add together 25 plus 36 plus 75.2 plus 83? No question about it. It's much easier just on the second ones. Okay? And I'm not saying this to waste my breath, but also think of this. On a CNC machine, a CNC machine only uses decimal. In other words, a scale of 10. Okay? That is how a CNC machine works. Now, if you use inches, and on easel, when you're going to jog your machine, you need to use the intervals. Now, the intervals, let me just pull it up real quick to show you. Okay? Let me see if I can get you turned around here. Okay. These down here are the intervals. So this right here, right now, I'm on millimeters. So 10 means that whenever I press any of these buttons, my machine is going to move 10 millimeters. Either 10 millimeters to the right, 10 millimeters to the left, 10 millimeters forward, or 10 millimeters backwards. Or if I hit my Z-axis. But I tell people, never move your Z-axis when this is in 10, because probably you'll crash it. If you're going to move your Z-axis either way, go to 1 millimeter. Okay, now, over here, if you have this in inches, if I put this in inches right now, right there, this here is 1 inch. This is 1 inch. If I click on here right now, my machine, boom, just moved exactly 1 inch. The next one, 1/10 of an inch. Okay, now you people out there that know your inches, how are you going to measure 1/10 of an inch? You can't, unless you have a decimal machinist's inch ruler, which is also ridiculous. Stay away from inches with these machines. You're just shooting yourself in the foot by using inches. Okay, now, why do they have all these different intervals? I'm going to go back to millimeters. The first one is 10 millimeters. Every time I push one of these buttons, it's going to move 10 millimeters. Then the next one is 1 millimeter. And every time I push one of these buttons, it's only going to move 1 millimeter. Then I have 1/10 of a millimeter. So in other words, if I go to here, if I click 1 millimeter, if I click there to the right, and then I click over here, and I want to come back to that same place, I got to go the opposite direction. I got to click this 10 times. Now, clicking that 10 times with 1/10 is exactly the same as 1 millimeter. This is just 1/10 of a millimeter. This is 1/100th. So in other words, here you have $10, $1, a dime, and guess what? A penny. That's all it is. 1/100th, 1/10, 1, and 10. Now, the reason we use these is when you are creeping up on your 0 point. And when you are going to creep up on your 0 point, you want your tool to come down and you want it to be exactly right on the top of your wood without going into the wood and not being over. If you are 1 millimeter over, your whole project is going to be 1 millimeter off. That's why I say everything you do with these machines should be exact. Because when you do everything exact, guess what? Your project is going to come out exactly beautiful. So I mean, when I'm touching off on my 0 point, I go all the way down to 1/100th, and I use a piece of paper, and I keep sliding my paper back and forth the whole time as I'm bringing it down until that paper stops. And then I just leave it there. I don't even lift the tool up. I leave it there. Because when you hit carve, eventually it's going to lift the tool up. And when it does, you take your piece of paper out. You don't have to go and try to pull it out. Just leave it. 0 point is very, very important. Okay? Because when you set your 0 point, you are telling your machine, right here is my X0, my Y0, and my Z0, which Z0 is the top of your wood. Okay? And now, by telling your machine, hey, listen, I have my tool resting exactly on the top of that piece of wood. Well, that what you're telling your machine is, okay, this is the length of my tool now. Now you know the length of my tool, and you know that it is at Z0, so everything is reset to Z0. Okay? So Z0 has to be perfect. I mean, not a 0.5 millimeter over, and not pushed down into the wood. Because it's real easy with those engraving tools. Let me tell you, it is very, very easy. Wait a minute. I'm just going to get it out here for you. Now, I'm going to tell you a little secret. Now, these engraving tools, you have to use that paper. And you have to creep up. That's why I go down all the way down to 1/100th of a millimeter and just keep hitting until this just grabs the paper. Because if not, you will drive that little tip right into the wood just like that. Okay? And the reason I'm saying this, for example, I have been in a situation. Now, these tools here are garbage. The ones you got with your machines, the Chinese are not going to send you any expensive tools. I'll guarantee you that right now. The Chinese are the cheapest penny pinchers there is. Okay? So, these tools here, they cost roughly $1 each. These are garbage. But they're very okay for you to learn to use your machine with. These are very okay tools to learn to use your machine with. Just like these tools here. These are $1 each. These are $1 a tool. They are garbage. But they work. And they're okay to learn with. I mean, you'll probably feel, if you use one for a project, it will probably be wore out. And since I'm on that subject there, never be a hoarder of old tools. Okay? Never be a hoarder of old tools. Because, and I'm telling you this because of experience, okay? I'm a hoarder. I am a hoarder. I hoard everything, anything. I mean, I'll have now I'm getting from the peanut gallery over there. I hear a yup. But yeah, now, what I was getting at was, if you hoard old tools, what you're going to end up doing is you're going to end up putting an old wore out tool in with your good tools, and then one day when you are going to use a $25 piece of wood, okay, and you're going to carve something really nice on it, and you put that tool in thinking that it's a brand new tool, and you put that old wore out tool in, and you make that carving on your $25 piece of wood, and it looks like garbage, guess why? Never hoard tools. If you do hoard tools, put them completely separate and away from your CNC tools. When you take a new CNC tool out and you use it, and you think, okay, it's still not quite dull yet, okay? Mark it. Put it in something where you know that it is used and it is on the way to be dull. Or get rid of it altogether. Because if you hoard them, you will screw up. I will guarantee you that. Okay? Now, when I said that these tools here cost $1 a tool, okay? They are garbage. If you are going to buy a true CNC milling tool, here's one right here. This is a double end, exactly the same size on both ends, okay? And what I usually do, I'll cut them in two. I'll cut it right in two so I can get that whole shank up in there. So when I'm cutting just with that much tool. This tool here, this is about a $48 tool. Okay? $48. Now, you put this tool, you get yourself a $48 tool. Oh man, I just got me a 3018, and guess what? I just went down and I bought me a $40 cutting tool. Okay? And you put that $40 cutting tool in your machine, and you line it everything up and everything, okay? And you hit carve and go, okay? And all of a sudden your machine is heading directly for the clamps. And guess what? And your tool comes over and it says tick, 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 a little tick. That's all you hear. A little tick. And guess what? You just broke a $40 tool. Gone with the wind. Okay? Now I'm telling you, I only teach you people from experience. Everything that I have been telling you not to do, I have done it. And I have screwed up. And after a while, I learn. Okay? And I'm just trying to keep you people from doing the same dumb stuff that I did. So, do not hoard tools. Another biggie. Newbies. My God. Oh. You know, I start teaching somebody that just got their machine, and they're already asking me, well, what about V tools? Okay, this is the only V tool you are allowed to use while learning to use your machine, your 3018. This is the only, this engraving tool is the only V tool, tapered V tool that you are allowed to use. Okay? Absolutely. Get it right out of your head. That crap with V tools, these 60 degree, 90 degree. If you want to make a lot of firewood, go for it. Go for it. But what I tell my students, learn to use your machine 100%, where you are a master with regular cutting tools first. Because V-Tools, if you don't have the Pro version, you have to know trigonometry, and you have to know geometry to even be able to figure out what the cutting diameter is. Okay? And I can tell you right now, a 90-degree tool, okay? Guess what? If you are going to cut 1 millimeter deep, guess what? The diameter of your tool is going to be 1 millimeter. If you're going to cut 2 millimeters deep, guess what? It's going to be 2 millimeters, because that's the way it works. It gets wider and wider the deeper you go. And on a 90-degree tool, it is exactly, the depth is exactly the same as the width. Okay? Only on a 90-degree tool. Okay? So, stay away from V-bits. They will ruin your projects. They will ruin your day. I'm telling you, okay? Don't do that. Don't go ruining your day for by using the wrong tools. Okay? Just stay away from those V-tools. Like I said, a lot of people think, oh, they're really cool. But everything that I do, let me show you something else here. Here's something that I turn you around here. Here's just something that I started the other day. Now this is laser engraved, and then I did my name in layers. Okay, the banner is the bottom of the banner, or the background is one layer. The one part of the banner is another layer, then another layer underneath my name, and then my name. And then the reason I went so deep is I am going to carve all these edges out myself by hand. So all this is going to be gone. But I made that like that, and then I'm going to have Buffy's name up here. But same thing at the top with Buffy on it. So that's layered carving with a banner behind with a laser engraving. Okay? So, back to tools. I don't recommend you buy high-dollar tools when you are learning to use your machine. No high-dollar tools. Unless you got a lot of money to spare. Okay? And these tools here, tool size for this, 0.1 millimeters. And this should never be used deeper than 2 millimeters. Best at 1 millimeter, or on plexiglass, 0.5 millimeters, or acrylic, 0.5 millimeters. That's where you get the best carvings. Okay? Here's another one that I did, which is just one of the icons in the drawing area. Okay, now this here is this is a 0.5 millimeter deep, and it's actually more than enough. Okay, and when you put light to it, let me see if I can show it to you down here. Yeah. Now I'm putting light to the edge of it, so it really makes it pop when you put light to it. I'm trying to get it. You see there, when I put my light to it right there? I mean, it really... And you can get these really cool bases. They got these really cool bases you can buy online, and they have LEDs in them. I'm sure you people have seen the post in the group the acrylic with flames, very, very cool. And that base that lights it up, you can buy them online. Okay. What else we got here that I can talk about? We talked about machine. We talked about maintenance, troubleshooting. Okay, now a little bit about troubleshooting. Okay, this is pretty. Actually, this is kind of interesting. Let's say you're doing a carving. Okay, you're gonna be doing a carving that, and on your carving, you notice that the lines that are going this way, okay, that are actually controlled. Your spindle is going to be moving in X mode, okay? In X axis will be going back and forth, left and right. But if you see that your line is not perfectly straight, that it's kind of wavy, or there's something wrong, and it is not perfectly straight, well, then you probably have a Y-axis problem. Okay? Because that Y-axis is the only thing that's going to give you variations as you're moving along. This here is on rails, so it's going to go exactly straight. But if your Y-axis is screwing up, it's going to give you wrong indications this way. If your X-axis is wrong, it will give you variations this way. Okay? This way. Because the table moves exactly forward and exactly backwards, but if this is off, it will give you a wavy line in your Y-axis. And if your Y is off, it will give you a fault going in X-axis. Okay? And so, for example, if you find out that, I think I have a problem with my Y-axis going back and forth. It's not going smoothly or something. When you power off a 3018, every one of these lead screws, you should be able to turn by hand with absolutely no problems whatsoever. Okay? And that's this one down here. This one. You should be able to turn that. So if you're having a problem with your Y-axis, what do you have in your Y-axis? Okay, you have your board, which is controlling your stepper motor back here. That's all. You have the board controlling the stepper motor. The stepper motor is turning your lead screw. Your lead screw has a lead screw follower nut underneath here. Okay? So, let's just say that you were going to carve a straight line, and you noticed that it was like this. It wasn't completely 100% straight. Well, for example, you take your table and you try to move it. If you found that you could move it a little bit, there is something loose. And guess what it would be? It's not this ain't moving. This ain't moving, but your table is moving a little bit. Guess what? You have to think logically. What is attaching the table to the lead screw? My lead screw follower nut underneath here. And if that lead screw follower nut was not installed with blue Loctite, and it comes loose on you, guess what? You're going to get a screwed up straight line. The line that is supposed to be straight, it's going to be wavy, or it's going to be wrong. So if there's any play in your table whatsoever, then it has to be your lead screw follower nut or your whole stepper motor back there that has come loose. Or let's say you want to move your table and you hear the motor go rrrr, rrrr, and the table does not move. What could it be then? How about the collar on the back, the collar between the stepper motor and the lead screw, the collar that attaches the lead screw to the stepper motor? How about that? Maybe that is loose and your stepper motor is just spinning. Okay? So you just have to think logically. Okay, if I wanted to move my y-axis, so in other words, I want to move that stepper motor, which is going to move my lead screw, which through my lead screw follower nut, which is attached to my table, it will slide on the ways. Okay? And the exact same thing for x-axis. It's exactly the same, except it goes that way. This one goes that way. And your z-axis goes this way. That's the only difference. You have three exact axes. Three axes that do the same thing in three different directions. That's all. That's all. Now, another thing you have to understand about your 3018. There are three different softwares that are involved in your machine running. Okay? Three softwares. You know Easel. Easel is one. Easel is the one I'm going to start teaching tomorrow night. All right. So, you have Easel. That Easel is a CAD-CAM, full-blown CAD-CAM program. Now, if you don't know what CAD-CAM means, CAD-CAM is, CAD stands for Computer Aided Drawing, which is the left side of Easel, where you do your drawing. It's Computer Aided Drawing, okay? On the right side of Easel, where your preview is, that is your CAM side. That is your Computer Aided Machining. Okay? So, that is a full-blown CAD-CAM program which will do everything for you. And it is a very, very powerful program to be a free program. It really is. I mean, I'm going to show you tricks on Easel that we're going to go into tomorrow night. And I'm going to show you guys exactly how much you can do with Easel. But the first thing you really, really need to understand is the 0 point. Okay, and that is the first thing I will be talking about. Now, one thing you do have to understand is that on your 3018, the 0 point on your 3018 is what we call a floating 0 point. In other words, wherever I move my machine to, if I move it over here, if I move it right here and right there, and I bring my z-axis down, which I can't because I gotta fix it, but anyways, and I bring my z-axis down, wherever I put my 0 point down on my material or whatever, okay, then that's going to be my 0 point. I can have my 0 point any place I want on my machine, anywhere. You determine where your 0 point is going to be on your machine here by putting your tool down. And since I am at it, I'm going to talk about clamps. Clamps, these that you got with your machine. Now mine are modified a little bit. I put these knobs on, which make it easier, and I've made a little plastic. I use plexiglass, okay? I just use plexiglass, and watch this. These clamps slide exactly right in there. Let me move this out just a little bit. Okay. All right, now I'm going to show you guys some stuff here. And I just got to find what I'm going to tell you here. And I am going to show you the correct way of how a clamp should be used, because a lot of people screw this up. Now, let me get as much light as I can over here. Let me bring it forward a little bit more. All right. Now, you've heard people talk about, let me take you out of here so I can show you better. Now, you hear people talk about waste boards, okay? Waste boards are a waste of your time. Exactly what I said. Waste boards are idiotic and a waste of your time. And why do I say that? Okay, first of all, in easel, you put in, right here, you put in the exact thickness of your material, okay? Right there. You put in the exact thickness of your, which is measured with calipers. So you put the exact thickness in there. Okay, this is a smart machine. It knows how thick your material is. So if I had a 1/8" tool, one of these here tools here, in my machine, and I wanted to cut out, as a matter of fact, here it is. Remember I showed you that inlay? Well, this is what I cut my inlay out of. Okay? So, when I put this on my machine, first of all, my machine knows exactly how thick that material is. And when I put my 0 point down on it, it knows it. It knows how thick that material is. When you tell in easel that you want to cut something completely out, that tool, your tool does not go any deeper than the thickness of your material. It will break through right at the bottom. And people, okay, now if you were going to have a waste board for this piece of wood, then you would have to have basically another piece of wood, basically the same size, okay? Basically the same size, so that you can get your clamps up, okay? You have room, because if it's too much, if it's bigger, I mean, if your waste board is like that, big, you can't even get your darn clamps up there, okay? You see what I mean? So you're going to have to find a piece of wood that's basically the same size as your piece of wood. Or why don't you just do it the simple way? Just forget the stupid waste board. Like I said, waste boards are a waste of my time. That's all you take is from one piece of wood. From one piece of wood, you cut yourself some strips that you know are exactly the same height, okay? These here, I can run my finger over, and I cannot even feel that there is a ridge, okay? These are exactly the same height. Watch this. Watch this. Ooh. Now this is what I call AFM. Huh? How much simpler can it get? Now, I'm gonna adjust my tool, my clamp, I mean. This is your jack screw. It's the one that goes in the threads, okay? And this is the one that is used to adjust up and down on the back of your clamp. So, whenever you are going to use one of these clamps, your clamp should be completely parallel with your piece of work. And look at this. Just clamp a little bit, and it is completely parallel with my piece of work. It's not like this. If it's like this, you're going to be pushing your work away. If it's like this, you're going to be making an indentation in your piece of wood. And look at this. This is my whole wasteboard right here. That's my whole wasteboard. Huh? Now, wasn't that a lot simpler than trying to find a piece of wood? Let me just adjust these here a little bit so I can. Just a second. Okay, now here I just bring it up to here. Move this a little bit forward so I can get down to here. And I bring that down by screwing that screw there. And I tighten it up. And with those plastic things at the bottom, I can do it all with one hand, right there. Boom, boom, boom. My material is off the table, so now I can cut anything I want out because it's only going to go right to the bottom of the wood, your tool, okay? And that's all you got to do is use two little pieces of wood instead of trying to find some stupid wasteboard, okay? Wasteboards are a waste of money and a waste of time. Make yourself some standoffs. I'm going to show you what we use in the real CNC world on big CNC machines for standoffs. Right there, we use 1, 2, 3 blocks. This is 1 inch by 2 inches by 3 inches. So it's 1 by 2 by 3. And this is what we use on CNC machines. We will put our piece up on there and we will clamp it down, or we will put it like that and we will clamp it down. Now, believe it or not, on a 20-foot CNC machine, if I am going to do a job on a CNC machine, even a 20-foot one, I will run my hand over the table. If I feel one tiny mar where maybe the tool has hit it or somebody dropped something on the table and made a little mar, guess what? I will be sitting there with a sharpening stone on that table like this. Getting rid of every mar on that table, because every mar is inaccuracy. Okay? So, this is I've just been covering the 3018 tonight. Tomorrow night, we're going to get into the cool stuff, and we are going to get into easel. Let me see. I'm just going to look here real quick. I'm just looking at the questions. Yes, Bill McDonald says, yep, if somebody's already put their machine together and you did not use blue Loctite, just take one screw at a time and do the whole machine. Oh, okay, Matt Lowe. You like my spindle? Me too, buddy. Me too. Believe it or not, when these machines first came out, this spindle motor, wait a minute, I'll turn you around here. This spindle motor is 55 millimeters, okay? The little one is 45 millimeters. So, we actually started out making our own brackets, and these are, let me show you. Let me show you. Where has my Z-axis gone? Where can it be? Oh, here it is, damn, right in front of me. Okay, here's a Z-axis, okay? And what we literally did was replaced this bracket with a 3D printed bracket, which is, I got a 3D printer here. So I printed this bracket, and that's the way we did it back then. You would have to take this whole thing apart, this whole Z-axis apart. You take this off, you take these bearings, you have to manually use a what do you call it? Not a burnishing tool. I got a brain fart. I can't remember what that reamer. A reamer. Because these holes have to be reamed out to exactly 15 millimeters. Actually, you ream it out to 14.95. Because when you press the bearings in here, then you want it to stay in there. Anyways, this was the old days. This is how we did the upgrade back then. The 3018 is only about maybe 2 years old since it came out, since it was introduced to the market. It's not very old at all. But now they're coming out with really, really cool upgrades. Really cool upgrades. And this one here, this is the baddest, because this motor here, this is a 500 watt motor, 1200 or 12,000 RPMs, and it's a beast. And it will tear up some wood, let me tell you. So you can increase your feed rates with that, but you just don't want to go nuts. Your machine is still a 3018. That's like they say, you know, when you can have a Volkswagen, and you can put a Porsche engine in it. Okay? You can put a Porsche engine in a Volkswagen. But guess what? You don't have a Porsche, you still have a Volkswagen. Okay? And you have to take care of it thereafter. You can't expect a Volkswagen to handle on the road like a Porsche would. Okay? Now let me just read some more of these here. Wayne is here. Hey Wayne, glad you could make it, buddy. Robert Perron. Hey Robert, glad you could make it too. And Kevin Duff. And let me see here. Kevin Duff. Thank you, Kevin. Have you found that one particular brand of cutting and engraving tools is a step better than the rest? Yes. Yes. Go to the people that make easel, inventables.com. And that is one of the, probably not tomorrow night, but the next night. Bo, you better follow with me, because I am going to show you people where to find everything. I'm going to show you how to find cool things off the internet. Boy, my throat's starting to get bad. The 2 hours. Yes, thank you, Cindy. I feel much, much, much better. I really do. I'm about 90%, but I have been bedridden for almost 2 weeks. I was really, really bad. Bacterial infection in my throat which went down to my lungs, and I was hurt. And with COPD, that doesn't help either. But yes, Dan, the tools, I am going to cover that up and down sideways about tools. Okay? So I will be doing that. If I don't think I'll have a chance tomorrow night, because when I get into easel, boy, I get into the nitty gritties of easel. I'll show you every button, every option, I'll explain it to you so you people will understand it. Okay? Moran says, yes, sir. That's Viking. Yes, sir. It's a 1/4 inch straight 2 fluke for jogging out with no problem. Not jogging, hogging, roughing, not jogging. Steve, correct terminology. Okay, all right. And then he corrected. I use 1/4 inch hogging out. Thank you. Yeah. Ann Sarver, will you be sharing best practices for switching from carved to laser? Yes, ma'am. Guess what? That is on my agenda. Because I'm going to be doing tonight, the 26th, the 27th, the 28th, the 29th, and the 30th, and New Year's Eve, even. For you people that don't have anything to do except stay at home and watch me. I mean, heck, what's cooler than that? Oh, boy, I like messing with you people. Okay, yes, I will be covering laser, GRBL, and everything, how to hook it up, and I mean, everything with a 3018. Yes. Hi, I'm new to, Lean. Okay. Hi, I'm new to CNC World. You came to the right place. Here, you are going to get it with a teaspoon. I will teach you. You will feel 100% confident when I am done with you. Okay? So, when I teach my people in my group, first of all, it is free. I teach one-on-one, face-to-face. So I basically know most of my people face-to-face personally in my group. That's what makes my group much more special than the other groups. Not to brag or anything, but thank you for doing this series. The STEM program here is very hard to get into, so this is my way of learning all this, and I really appreciate it. You ever heard that song? I ain't seen nothing yet. Okay? You ain't seen nothing yet. I'll tell you what. You wait. Just hang in here. You hang around here. You hang around here in this group here. Best place to be. I can turn you into a CNC operator. Actually, what I teach my customers, every customer or member that I teach, I am basically giving them an $800 CNC operator's course. Okay? And I love it. I love teaching. I love running my mouth. Once again, excellent job tonight. The cigarette doesn't help you and talk about inches. Jim, I know. Actually, we're quitting. New Year's, that's it. So, right now, I am in the winding down, or actually, I'm smoking enough to make myself sick, because that's the only way I can quit, is I have to beat myself up so bad that I'll quit. Thank you, have a great night. Nothing is cooler than that. Okay, my mom wants to know if she can make some money, a money contribution for all this. Huh? No. No, no, nobody is going to contribute to me because, first of all, I do not need the money. The reason I do this for free is because I love to teach, I love to run my mouth, and wouldn't it be a damn shame for me to take all this information and knowledge to the grave with me? I think that would be really, really selfish. So, I would rather teach you people for free, expecting that when I am gone, that you people pass it forward and teach others. And also, doing this keeps my brain sharp too. Okay? So that's why you got it. And no contributions, nothing. Nope. But thank you very much for it was a very, very kind thought. But nope. Wait patiently. That is awesome. Good BTO, yeah, boy. Yes. Thank you, Cindy. I agree with Paul. I appreciate all your efforts to teach, Paul. Thank you. Steve, it's okay, buddy. I like doing it. Ursula Johnson, thanks for sharing your knowledge. Just about to pull the trigger on purchase, but thought I'd join and learn from the series first. Good woman. Smart, 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 smart. Very cool, very cool. And let me tell you something. If there's anybody out here that is planning on buying a machine, a 3018 or something, by all means, if you have the means to buy it through Amazon, do it. Because Amazon, now all of these major Chinese companies are selling through Amazon. So these Chinese companies, you can get all the stuff they have through Amazon. And guess what? They have to follow Amazon's rules, including money back guarantee. You buy through Amazon, you are guaranteed your money back if you do not like the machine, if you find out it's not what you wanted, or if you found out it's a lot more difficult than you thought it was going to be, you can get your money back. Okay? So, if by all means, try to, in some cases, you're going to find that it might be a little bit more expensive on Amazon, but you have that guarantee, okay? Hope that's a long time away. I'll tell you what. You know what? I have to just say it, I was out the other day, and I just don't understand what is wrong with people. People that were out driving, I'm talking maniacs. They have zero consideration for other people. They don't care. They only think about themselves. They got this telephone on their face while they're driving or they're texting. I mean, idiots. And to be honest with you, I came home and I told Buffy, I said, you know what? The rest of this country and the rest of this world has surpassed my stupidity level, my tolerance level. I don't belong here anymore. Really. I just can't get over it. I cannot get over how ignorant some people are, how disrespectful they are. This new generation has absolutely zero clue what customer service is. I mean, you go to McDonald's or Hardee's, there's nobody there. I pull in, I order one hamburger without onions, and guess what? They screwed up. Now, that's when Paul gets really... that's when the submarine sailor comes out, okay? And yes, I am a submarine sailor. So, I do not swear like a sailor. I am a sailor. So if you swear like a sailor, then I am your role model, okay? Let's get that straight. If you don't know, I quit. Jim, that's okay, man. We are. Yep. Oh, don't worry. I promise you that after New Year's, this is gone. Gone. Now, I've been talking for over 2 hours now. You can hear it on my throat. I can feel it on my throat. And I got to get it all mo better for tomorrow night, you know. So, I want to see you people here tomorrow night. Yes, Bubblehead, yep. And all the surface ships, you know what they are? Targets. Yep. I've lived underwater for 2 years and 4 months. Underwater. 3 months at a time without coming up. Yep. Yes. So, with this, I am going to sign off of here, and I'm going to go pamper my throat and everything, you know, so I'll be all ready for tomorrow's session. And tomorrow, we are going to talk about easel. And I'm going to show you people things on easel that you're going to say, whoa! Yeah, really. It'll blow you away. It'll blow you away. Ain't my first rodeo. But, listen, you know what, tonight, do you know that there was up to 20 people on there tonight? I couldn't believe it. I mean, I think my record before was 10. And we hung at, well, we were up at 20, we hung around 18, 19, then got down to 15, now we're down to 9. But that's okay. I know who wants to learn, okay? And I'll tell you, I have people in the group that I have offered 3, 4 times. Listen, I see what they're doing wrong when they post things. I see what's where the shoe is hurting. And I say, look, you know, give me a couple hours of your time and I'll teach you. Face to face, I'll teach you this. You will learn it. You will know it. Within 2 hours after I teach you, you will know it. They don't accept the help. And I keep watching them, and they keep doing the same things over and over. And then they ask the same questions. You know? If I had taught them, they would have known all that. But, anyways, I am going to get off of here. And I'll see you people tomorrow. And I really hope that all of you had a wonderful Christmas. I did. I really did. I got some really cool... Oh, I can show you guys one evening some of the cool toys I got. The only difference between a man and a boy is the price of his toy. Okay? Okay? All right, guys. See you guys tomorrow. Have a wonderful evening. As that guy does on Forged in Fire. Okay? All right. And this video will be in the group, up in the photos tab. Okay? Have a good evening. Bye.